Good evening to you all, everybody, and welcome to day 6 of our AWS Cloud Computing Training, preparing for the CCP certification examination. CCP stands for Certified Cloud Practitioner. And so after this particular examination, you are going to be a certified cloud practitioner because you are going to understand the tools of the cloud. You are going to understand AWS, and this knowledge will help you in every area of your tech journey. And today we have something very powerful, something very important to learn that will give you new information, new education, and make you better than you were yesterday. I'm going to start the class with a short clip. Let's watch this particular clip to refresh our memories on elastic beanstalk, what we studied yesterday. And after that, we will zoom in into today's lesson. Today, I'm going to introduce a new concept known as containerization. Containerization. If I'm audible, please put containerization in the chat for me. And it's going to be an interesting topic. It's going to be something that will marvel you, something that will excite you, and something that you'll be happy you were in class today. So thank you all, containerization. I'm going to play one clip and then I'll give you a quick overview of the AWS services and we'll zoom in to containerization. Let's get ready for that.
Finding the right tools to migrate, build, or modernize your cloud-based web app can be complex. With all the choices available, it can be difficult to know which ones to use. And afterwards, it's up to you to manage multiple services to provision infrastructure, handle deployments, and scale your web app. What if you could instead focus on writing code and building great web apps? Wouldn't it be nice to not have to worry about provisioning services, scaling infrastructure, or updating your platform with the latest patches? AWS Elastic Beanstalk is an easy-to-use service for deploying and scaling web applications and services developed with Java, .NET, Node.js, Python, and many more on familiar servers like Nginx and IIS. Elastic Beanstalk automatically manages the services needed to host and scale your application. Getting started with Elastic Beanstalk is easy. Migrate your application by uploading your source code bundle to Elastic Beanstalk using the Management Console or command line interface. Elastic Beanstalk returns a URL for your new web app and automatically handles the deployment details, such as provisioning, load balancing, auto-scaling, and application health monitoring. You have the option to configure your web app to run on your preferred instance type, or to add resources such as a virtual private cloud or a relational database. Elastic Beanstalk also provides a pathway to modernization. You can re-implement portions of your application as containerized services. Then, by linking to your existing web app, create a distributed application. With Elastic Beanstalk, you can retain control over the AWS resources powering your application, allowing you to manage as much or as little as required. Even better, there's no additional charge for Elastic Beanstalk. You pay only for the AWS resources needed to store and run your applications. With Elastic Beanstalk, you can focus on building API services, web backends, websites, content management systems, and even SaaS applications without spending a lot of time managing and configuring infrastructure. To get started, visit the Elastic Beanstalk console and get your web app running in the cloud in just a few clicks.
All right. When we started this journey, we got introduced to cloud computing in general. We got introduced to the cloud service models like IaaS, PaaS, SaaS. We talked about the benefits of cloud computing, the advantages of cloud computing, and we understood how important it is to learn cloud computing. And learning cloud computing is something that has revolutionized the world. Introduction of cloud computing has revolutionized technology, has advanced technology, and it is an important skill to have today as a tech professional, no matter where in tech you are branching to. When we started learning about Python and all that, you have seen how Python is in cloud, and every day we hear about Python everywhere. After that, we got introduced to AWS. We learned about their global infrastructure. We talked about their services. We moved on to talk about their compute, their storage, their database services, and we are diving deeper into the core services one at a time. We've talked about EC2, we've talked about Lambda, we have talked about Elastic Beanstalk, and we are moving on. All these lessons together builds that foundation you need to understand cloud and to succeed in this certification to become a certified cloud practitioner. My hope is that you are still learning and you still remember everything we have studied. If you missed any lesson, all the videos are available. The slides are also available. Please refer to the videos and make sure you catch up. The lessons we are having now will upgrade you, will make you better in your mind, make you better in your understanding, give you a stronger foundation in technology. I have been in technology for so many years, and when you are in the middle of something that is moving you higher and moving you forward, I can easily see it. And this particular course is an incredible course that is preparing you for modern technology. And so, even if you don't have a long experience in technology, following this course carefully will help you get an understanding of modern technology. And today, we are going to introduce something new, something that is revolutionizing technology in the whole wide world, and something you should know about. I'm going to start by giving you a quick overview of the AWS services. I've always mentioned how AWS started with just 3 products, and I've been using this particular story of an incredible woman who started her business with 3 products and gradually moved on, scaled the business, and now has a powerful business. I've always been telling you that in your career, in your businesses, if you attach the same dedication, the same excellence, the same hard work, the same commitment, the same consistency, you will also scale up. In yourself as a person, you will scale up from a smaller version of you to a bigger version of you. So this business you are seeing could be a person. Maybe today you only know 3 things. You know about word processing, maybe you know about email, and you know about Python. Maybe that's all you know. But as you upgrade yourself, you are going to know more things. You are going to add more to your knowledge. You are going to have a lot in your toolkit, in your knowledge base. And a time will come, you take the world by storm. This could be a picture of your life. This could be a metaphor of your life, telling how you are growing from strength to strength. And the same applies to everything you will do. Amazon Web Services has excellent attitude to customer service and how they serve all those who need their services. They attach that attitude to Amazon.com, and the e-commerce website grew from a garage to #1 in the whole world. You cannot move from a garage to #1 in the whole world like that. You need to have some special qualities, some special attitudes. That is what you need. That is what everyone needs in this class. We need to be good. We need to be consistent. We need to be committed. We need to learn hard because nothing is built in one day. That same customer service, they brought it to AWS. And from 2006, Amazon Web Services has grown to #1 again in the whole world. as a leading cloud provider in the world. They started with 3 services: EC2, S3, SQS. And SQS is for messaging, S3 for storage, EC2 for compute. As demand grew, they kept on innovating and adding to what they do. After a few years, they were able to create so many cutting-edge services that each one is enough to run as a company on its own. EC2 alone is enough to run as a company. As a matter of fact, all the web hosting companies and all those who have data centers and are providing web services around the world, all of them, none of them can compare to what EC2 alone is doing. This means EC2 alone is bigger than all the companies trying to provide cloud services. And EC2 is built upon the global infrastructure of AWS, and they keep growing. S3 the same, SQS, and all the services we are learning about. When it comes to their compute services, we've talked about EC2, Lambda, Beanstalk, and we are getting ready for ECS and EKS, and we will end compute with Lightsail. If there's time, we'll chip Fargate into it, and we'll do our best to complete this by tomorrow, so that next week we will wrap up the rest with speed. So today we are going to set a foundation that will help us to be able to learn about ECS and EKS, because they are container services. And so we will learn what Elastic Container Service is, ECS, and what Elastic Kubernetes is in AWS. For the storage services, we learned that we have S3, very popular. We have EBS, Elastic Block Store. We have Glacier for archiving. We have FSX, which is a file system on AWS. We have Storage Gateway that allows you to connect your data center to AWS. And for databases, we have the popular RDS, Relational Database Service, that allows you to connect all your MySQL databases to the cloud. And it is powerful for every relational database management system that you want to deploy in the cloud. Then we have DynamoDB, which works like MongoDB, and it's a NoSQL database platform. We have Aurora, which is AWS's relational database system, also works with MySQL. We'll get into that as well. And we have Redshift, which is a powerful database system for analytics, for data science, for business intelligence. We have DocumentDB, which is also a NoSQL database service like DynamoDB. So we'll take time and go over all of these. For content and networking and content delivery, we have Virtual Private Cloud, which we will learn very soon, which is a powerful service that allows you to create your own private cloud. And we have Route 53, which is a DNS service on AWS. Those of us who have been managing DNS for some time, this is amazing to know about, because on AWS, we can also manage DNS. And we have our CloudFront. Everybody knows about CloudFront. CloudFront is one of the most popular services on AWS. And this works with the edge locations to provide fast content delivery. We have Direct Connect, we have API Gateway or API services. For management, and everyone will be managing their AWS services. And so when you create your account, you are given the AWS Management Console. So when it comes to managing your AWS services and governing your AWS services, one of the most popular services is called CloudWatch. CloudWatch is so popular. and it is a monitor. It allows you to monitor all that is happening on your account and all the services you have. It can even monitor billing. It can set alarms to remind you of things, and it's a great service in AWS. We have CloudTrail, which also records activities in the cloud. We have Config, which is for configurations. We have Systems Manager. We have organizations, and these are the core services we are going to talk about and get an understanding of what they are for the AWS Certified Cloud Practitioner examination. We've been dealing with our compute, and again, we've covered some, and I'm so happy the knowledge we have acquired. If only you are following the knowledge we have acquired from EC2, Lambda, and beanstalk. And what we are going to do next is to cover the container compute services. So ECS is a container compute service. And for us to understand it, we are going to move to a whole new area. And it is definitely a compute service, and it uses container technology. So we're talking about containers, and all the compute services are computers. They provide access to machines. They provide access to servers. They provide access to work on AWS's infrastructure that they have set up to give you processing power in the cloud. And with these compute services, we use them to run our applications, to run our automated tasks and all tasks and workloads we have in the cloud. And each one is designed for a special use case. We have seen how Beanstalk is designed, and it's so wonderful. We've seen how Lambda is designed, and it is so interesting. We've seen EC2, and it's just amazing. Now we are going to move on to another concept in software engineering and cloud computing and all of technology called containerization. I've asked you to type this. Now, technology has advanced from old ways of doing things to modern ways of doing things. And one thing about the world and the industry is that all companies want to work with modern tools so that they can keep up with competition. They can leverage these modern technologies to save cost and to be faster and better, because whoever does the best leads the world. That is why when it comes to AI, the United States wants to lead, because whoever leads benefits and rules the world. And so when there is a new technology, it is important that we, the tech professionals, we also upgrade ourselves. And so when something new comes, we need to take time and look into it and understand it, because technology changes so rapidly. And what you know today may be outdated very soon, or new things are coming. And if you don't add the new to what you already know, and if you don't optimize your skills to work with the new technology, you may not be able to meet the industry demands. All right. So there was a time that large companies and service providers who put applications on the internet, and hosting companies who allow customers to buy space on the internet. All those who manage the internet and the cloud, they had a technology that they used. And we've all heard that previously, if you needed to put, let's say, an application or a website online, you would have to host it yourself. And it is very expensive to handle that. And so from there, we had companies that took charge of owning the machines that can put applications online. And what happened was that anyone who needed to put something online will become a customer and rent space on their services. If you have been hosting websites, you know this very well because the hosting company is just a tech company that has decided to build the machines and the infrastructure to be able to put applications online. Now, these companies were able to do that because they were able to get a lot of customers to come together. And because of the multiple customers, they were able to reduce the cost of their services, and everyone was able to get space online to put their applications online. If you have never owned a website before, you may find it quite distant to understand it. But if you've ever owned a website, you will know that you need space online to put your website. Now, these companies work with certain technologies. First of all, they all have data centers that they have to set up. So those of you in the Webmaster class, we saw Bluehost and their vast data center and all the technicians that worked in their data center. Now, all these technicians, they have expertise in specialized areas in IT. And they understood that to put applications on a server, certain technologies need to be in place. First, when they have a server and they want to launch applications on the server, they realized that multiple applications running on the same server created some conflict issues. And so a time came that it was difficult for more than one application to run on a single server. And sometimes these applications only use very little space. But running multiple applications creates conflicts and creates problems. And so what they did was that they actually brought new servers for different applications. And at that time, it was very expensive to manage servers because if you acquire a server, you can only use just a portion of it, maybe 10% of it, and the whole server is just there doing just one thing. This is how it was before until the technology of virtualization came. When virtualization came, virtualization allowed these technicians and tech experts to be able to simulate machines on these servers. And so on one physical machine, through virtual machine technology or virtualization, they were able to create multiple machines. This is what virtualization does. It allows you to create a virtual or software-based machine that operates like a real machine. And so when this virtualization technology came, they were able to host their applications rather on the virtual machines and set up multiple virtual machines to host multiple applications. And so virtualization solved a lot of problems with putting applications online. When this happened, companies started using this technology. Later on, we realized that virtualization consumes a lot of compute resources because each virtual machine needs an operating system, needs its own resources assigned, and the next virtual machine will also need set of resources, its own operating system as well. And every virtual machine on the same machine, on the physical machine, needs all of that. And so it is quite heavy and takes time to be able to run all these VMs on this physical server. But then that was the technology at the time. Today, there is a better technology called containerization that solves the problems that virtual machines are not able to solve. And so what you are about to learn is the modern technology for deploying applications online or in the cloud. So when you hear containerization, the first thing I want you to understand is that this is breaking news to you if you are not into containerization or you don't have knowledge about containerization yet. Because this is the future. Containerization is a transformative technology that has reshaped software development and deployment, mostly deployment. So what I'm telling you right now is that this is modern technology. And so as you have heard about it, now you need to explore it and see how you can understand it and possibly how you can also make use of it. Now, containerization is the process of packaging software code along with all of its dependencies into a single lightweight and portable unit called a container. If you can hear me, please type container in the chat for me. Container in the chat for me. Again, this may be the first time you are hearing about containers or containerization. But the first thing I told you is that this is modern technology. And so what we are going to do now is to do our best to understand what it is. So as I am explaining, I'm building the foundation for you to get the understanding. Now, this containerization allows us to package software into containers. Allows us to package software into containers. All right, so the first idea is this. When a software is developed on a system and we want to allow this software to be used by others, we want to deploy it, we want to send it to production, or we want others to use the software, usually we package the software. All right. Now, this containerization allows you to package in a container in a way that all the dependencies are added to the code. Let me explain that. Let's say I write code in Python and I build a Python application. On my machine, since Python is installed on my machine, I am able to run the application and use it locally. I'm able to use it. But if I give the .py file to someone, the person may not be able to run the application because they don't have Python installed or they don't have the software running on their system to be able to run the Python. And so it doesn't work. Now, with containers, I can put my code along with all the dependencies. When we say dependencies in terms of software development, we are talking about all the related files that make the application to run. All the related files make the application to run. And so if you use a programming language to write an application, that application is in the development environment, but it needs to be sent into a production environment where others can use. And it comes along with certain dependencies. And so if I'm able to take this Python file and all the libraries and frameworks and configuration files that the Python code needs, and I'm able to put all of that into a container, when I am giving this file to another person, I'll not give the person just the .py, I'll give the person the container. So containerization is a process of packaging into containers and deploying your software as containers. And so when this .py is run on anybody's machine, because all the dependencies are there, it is going to work. Let me give you another simple example. If you have ever created a simple web page before in HTML, you realize that you need to connect your HTML to a CSS file. If you have ever created HTML before, you need to connect your HTML to a CSS file. And you also need to understand that all the images in your HTML code or on your web page, they also live in another folder, and all the images are loaded from a separate folder. And so your HTML file is just a text file. It's just a text file. But when you run this file on your machine, it's able to display a web page with colors and images. Why? Because this text file with HTML code is able to communicate with all of these multiple files to make the web page work. I create web pages all the time. And anyone here who has created a web page before, you understand clearly what I mean. In our webmaster class, we all created some web pages, so you understand what I mean. And I'm going to ask you a question. If I take just the HTML file and I give it to someone else on their computer, just the HTML file, and they run the HTML, because HTML is actually compatible with almost every device. But when they run the HTML, are they going to be able to see the full web page with all the colors and all the images? Are they going to be able to see it? Okay, if you have an understanding, tell me in the chat. So some are saying no. No. Why no? Why no? Who can answer the question? Why no? Because everybody is saying no. Why no? Anybody who can answer that question? Okay. Why no? Okay. All right. Let's not even go into database website. I'm just talking about simple web pages with only HTML, CSS, and images. They don't have the other files like the CSS, you see? Wonderful. So when they load it, it's not going to show the web page. They are going to see only the HTML structure and the text within the HTML text document. In this case, the CSS that connects to that HTML is missing. All the images that connects to that HTML is missing. And so those other files, when it comes to software development, we call them dependencies. The dependencies are the additional files needed for one application or one software to work. So like a web page, they need all the dependencies. All right. I remember one time we created a software in C++ and we needed to deploy it into an installable software. So we needed a software that can do that for us. And so you need to move your code into that software so that you can create a setup for other people to be able to install it. That software said, upload the following dependencies. And we uploaded several DLL files, different library files. The software requested for them before it was able to create the setup for us. So once the setup was created, now you can give the setup to someone and the person can install it. And when they install it, they don't just install your application, they don't just get the icon, they also have the dependencies somewhere on the system so that they too can run it. Now, today we are talking about the modern way of deploying any application today, and this is containerization. These containers can run consistently and reliably on different systems and servers. And very soon, we are going to see why and how containers are better even than virtual machines. So what is a container? A container is a lightweight, a standalone, and portable unit of software. That includes everything needed to run the application. It has a code, it has a runtime, it has the system tools, the libraries, the settings, everything needed to make the software work. Again, this you are hearing is modern technology. And it's lightweight more than anything you know before. It's better than anything you knew before this. And it allows you to package your software into containers that makes it light, standalone, dependable. And because of the container, the software can be put anywhere and it has everything it needs to run. And so it can run from anywhere with no issues. There is a common problem that developers have. And I encountered it and I was laughing because I thought I was the only one who has come across that. But then I realized that it is everywhere. They say that it works on my machine. When you say it works on my machine, it means that you have deployed an application and everyone is complaining that it's not working. But you open it on your machine and it's working. So I was reading somewhere and I read that containerization solves the it works on my machine problem. And I was laughing. That's so this happens everywhere. There was a time I built a website and I deployed this particular website online for the whole world to see. I actually built it on local hosts. Those of you who have used the local host to understand it. And after that, I deployed it and it was online. But when other people visit the website, no image is showing. A whole lot of files are not working. The links are all not working. But when I open it on my machine, it works on my machine. How is that? Because I developed it on my machine, all the links were having localhost in them. Even in the database, all the links were localhost, localhost, localhost. And because my machine is a localhost, even though we have put it online, the localhost code in the background is still able to connect with my machine and we still see the website. But on other people's machines, there's nothing like localhost. So they can't see and they say it's not working and I don't understand it. Until I realized that we need to change all the links from localhost to the domain. And so we went into the backend and the database and we changed all the links from localhost to the domain name, and it was able to communicate with the dependencies on the server before it was able to work. This is a common problem that we encounter when we build an application locally and we put it online. It works on my machine. Now, this containerization problem allows you to work and package your application in a container. So when you move the container, nobody's going to have the problem of it works on my machine. Containers allow applications to run reliably and consistently across multiple computing environments, from a developer's laptop to a testing environment, and even to a production environment where the whole world can make use of it. And now we put applications that the whole world uses in containers. Containerization is a future of code deployment. Please put this in the chat. This is one of the information I'm trying to communicate to you. So today, if you don't know about containers, what it means is that you need to upgrade yourself because this is the future of code deployment. Containerization is the future of code deployment. So when it comes to putting an application online, containers are the future. Containerization is the future. I'm giving you breaking news. I'm giving you serious information and I'm alerting you, I'm urging you, and I'm telling you that this is the future because it ensures applications run consistently, efficiently across any environment with minimal compute resources. On top of that, it uses very less computing resources. And as I mentioned before the class began, when something is more efficient, companies tend to adopt it. All right, companies adopt it. So as a tech professional, if you have not heard of containers, then during the interview, they ask you and you are going to be lost. I remember someone lost an interview because they couldn't answer the question, what is continuous integration in software engineering? So you are applying to be a software engineer, you brought a powerful CV, you said you know all of these languages, you know this, you know that. During the interview, they asked a simple question. and the person started beating about the bush. That is where the person lost the job, right there. Another person couldn't explain the concept of object-oriented programming. The person was asked to explain abstraction in OOP, because in OOP, there are about four main concepts: abstraction, encapsulation, inheritance, and polymorphism. So the person was asked to explain abstraction in object-oriented programming. The person couldn't answer. That tells them a lot about you, that you are not modern, you don't know what is going on. And the last thing companies will do today is to employ someone who is coming to be a burden. They are not there to train you. They are there to leverage your skills to move their business forward. And so when it comes to modern tools, it is your job to be updated, because some questions, if you are not able to answer them, you are just lost. All right. So let's keep that. So why do we use containers? After this, I'm going to play a video that will explain all that I have said. And hopefully somebody in this class will understand the concept of containerization and will understand why this is the future, and will be ready to explore containers more. And when we go to AWS, we have Elastic Container Service. So for us to be able to understand the ECS, Elastic Container Service, and EKS, Elastic Kubernetes Service, the least we can do is to understand what containers are. And so today we are spending our time to learn about containerization, about containers. Then we'll move on to something called container orchestration. If you can hear what I'm saying, please put it in the chat. Container orchestration, another concept we need to understand. Container orchestration. I don't know if you can spell it. Container orchestration. Container orchestration. So we'll talk about container orchestration. Lois, you are amazing. You're amazing. Wow. Container orchestration. And then we'll start talking about the tools needed for container orchestration. And that is where we'll be introducing Kubernetes. And then we'll be introducing ECS. So in our next lesson tomorrow, we will do our best to cover all the container services. But to do that, and for you to be able to comprehend them, you see, all that we've studied so far, we've done well to wrap our minds on what they are and how they work. Because this examination is an understanding-based examination. Today, all that I have done is to build a foundation for you to be able to understand the container services on AWS. So we've talked about containerization. I've told you it is the future. I've told you some of how it works. Now we want to look at why we use containers, and we will add to our knowledge. Number one, consistency. Containers ensure that an application runs the same way in development as it does in production. So it ensures consistency, because if you package it in a container, all the dependencies are there. And if you move the container everywhere, it is going to have the same content. This concept of containerization is just like how containers can be filled in Europe and be shipped from Europe all the way to Africa. And when it gets to Africa and we open the container, we should see the same content. So wherever the container goes, then the content will go. We introduce in certain applications that are used to create containers and container images, and we'll be ready for advancing in this course. Number two, we use containers for efficiency. Containers are lightweight compared to virtual machines. So this technology of virtualization that we've been learning about, containers have become much better than virtual machines because they share the host system's operating systems kernel. We'll talk about that. Portability is another reason because a containerized application can run anywhere. It is portable on a developer's laptop, on-premise servers, or even in cloud environments. Because it is in a container, it can be moved anywhere and it works. For scalability, containers are amazing. They support rapid scaling to handle increased workload. And we have isolation. Containers provide process and resource isolation, reducing the risk of one application affecting another. So it is able to create an environment where only one application can live and work perfectly. So we have containers versus VMs, virtual machines. After I mention this on this slide, we will watch a video and we will get better understanding. So containers are more lightweight and efficient than virtual machines, making them ideal for scalable application deployment. So when it comes to application deployment, containers is a way to go. So what I'm going to do now is that I'm going to play the video. There are actually two videos. I want you to relax, take your time, listen carefully, understand everything that the video is saying, and let's build this foundation to be able to move forward. So if you are ready for the video, please put it in the chat for me and let me get a video ready for you. If you are ready, all right. So we have two people ready. All right. So let's get into this video. So all that I have said, I want you to digest it. Okay, because this may be new information to you. New information to you. One thing about technology is that sometimes when new information comes to us, it looks some way sometimes. Sometimes when you hear about new technologies, new things you don't know, they may seem some way to you. Just because you have not gotten into them, you have not explored them, you may have some assumptions about them. You may not even know their importance, and you may feel that they sound advanced and difficult to learn. And it's probably for a few people. Don't let the terminologies we use confuse you. Don't let the terminologies intimidate you. Don't let the terminologies make you not move forward. And what I've discovered over my years in technology is that once you get into them, you are going to understand them. So all that we have said today may be coming to you as a brand new information. But please pick the key information or details we are giving you and keep them in mind. Keep containerization in mind. Keep the fact that it is the future in mind. Keep the idea of containers and the concept of containers. And we have explained it that a container allows you to package your software code and all the dependencies in a box or a unit that we refer to as a container. And there are tools that allow you to do that. And so we will mention the tools we use to set up containers. So you'll be wondering how you can also create a container. We'll look at that. And so moving forward in your tech journey, when you hear about these tools, you will now understand how important they are and why you should learn about them and know how to use them, because companies are now using that. Let me share this video and we'll move on.
In this video, we're going to talk about the difference between virtual machines and containers. But before we talk about the difference between the two, let's go back and talk about how things were before VMs and containers. So the traditional way that a company or a business operates is by having applications running on servers. And each server would just have one application running, whether that application is running a website, a database, or email. So it would be one application on one server. And this was because the operating systems on these servers, such as Linux and Windows, didn't really have the capability to run multiple applications securely on a single server. So with each new application that a company or a business offered, they would have to buy a new server for it to run on. And on top of that, the application wouldn't be able to take full advantage of the server's capability because modern servers today are so powerful that oftentimes the server is only running at 10% of its capacity. So by running one application on one server turned out to be a big waste of money and also on the server's full potential. So to fix this problem, engineers developed virtual machines. Virtual machines allows multiple applications to run on a single server by simulating hardware and software. So for example, if a company had 3 servers running one application each, those 3 applications can be run on a single server by simulating those 3 servers and their applications by creating 3 virtual machines. So now this one server is running 3 virtual or software-based machines. It's running all of the different operating systems and also the applications, such as databases, web services, and email, and they're all running side by side on one machine. So as you can see on this graphic, to build virtual machines, you start off with hardware, such as a server. And then on top of the hardware, there's software called a hypervisor. A hypervisor is what allows one machine to run multiple virtual machines. It's what allocates and controls the sharing of a machine's hardware. Some common hypervisors are VMware ESXi, Citrix XenServer, and Microsoft Hyper-V. And on top of the hypervisor are the virtual machines, and each of these will have their own operating system, such as Windows, Linux, and Unix. And then on top of the operating systems, there's the applications that these machines are going to be running. So as you can see, virtual machines solve the problem of wasting money on new servers. But as great as they do have some drawbacks. And one of them is that VMs can consume a lot of disk space. And this is because each VM has its own dedicated operating system. And because they have their own operating system, VMs also consume a lot of RAM and CPU power from the server that could be used for other processes. And VMs are slow to start up because since they have an entire operating system, they do take time to boot up. And with each VM, it also requires a license for the operating system, which costs even more money. Now let's talk about containers. Now containers are similar to VMs, but the major difference is that where VMs simulate an entire machine, containers only contain an application. A container is an application that's been packaged with all the files, configurations, and dependencies necessary for it to run, which basically means that it's bundled with everything that it needs to run on just about any computing environment without having to add anything else to that computer. So for example, if a developer created a website and they wanted to distribute that website so it can be hosted on just about any other computer, they can create a container for that website by bundling it with everything it takes for it to be hosted on another computer, such as the libraries, HTML code, scripts, web images, and web server software. then that container image can be distributed and hosted on just about any computer or server without adding any additional software or doing any configuration. The container has everything it needs to run that website all in a convenient little package, which is amazing. And the leading software that is used to create, manage, and run containers is Docker. Docker can run on Linux and Windows machines. So just like VMs, to create containers, you start off with hardware such as a server. And then on top of the hardware is an operating system such as Linux. Now, instead of a hypervisor, containers will use a container engine. A container engine is what unpacks the container files and then hands them off to the core of the operating system, which is the kernel. So as I stated before, the major difference between containers and virtual machines is that each VM contains an entire operating system, which makes their file size larger, which is why they are slower to boot up. But on the other hand, containers don't. The containers share the underlying operating system that's on the server between them. Containers only contain an application, which makes their file size much smaller. And this is why containers are considered lightweight, which also makes them lightning fast. So while VMs can take minutes to boot up, containers take milliseconds. Containers also consume less RAM and CPU power from the server than VMs. Now, both VM files and container files are portable, which means that you can move them easily to different machines. But container files are a lot smaller, which makes them ultra portable. Now, containers do have some disadvantages when compared to virtual machines. And one disadvantage is that the container file or image must be packaged to work with the same operating system of the server that it's running on. So if the server's operating system is Linux, then the container file must be Linux-based. If the operating system is Windows, then the container must be Windows-based. But with virtual machines, this isn't a problem. A VM can run any operating system it wants. Another disadvantage is that since the containers share the underlying operating system between them, that means that if the operating system on the server crashes, then all the containers will go down. So you can clearly see that both VMs and containers are amazing technologies. In fact, some organizations use both of these technologies on the same machine, where they would have a server running VMs, and inside those VMs they would be running containers, utilizing maximum productivity. But that being said, Docker containers are clearly the future because of their size, portability, and speed. Hey guys, are you tired of keeping...
Okay, so my question right now, did you understand this video? Anybody? Did you understand the video? All right. Tell me one thing you learned from this video. Again, keep in mind that this is new information, may be coming to you as new information, but it is very important and very powerful information to prepare you for advancement. My question is, tell me one thing you learned from this video, anything at all. Tell me one thing. The VMs use hypervisors, containers use container engines. Lois, thank you so much. Thank you. Thank you. Containers are more cost efficient than virtual machines. Containers have fast boot time. Wonderful, well done. Let's watch out. Great people are coming. Wow. Well, I was going to say that we are very smart people amongst us, and we are preparing for the future. And somebody said containers are the future. Of course, containers are the future. So as we are learning about modern technology, we are also becoming modern. Yes, containers are lightweight. Containers are quick to boot. Containers can host multiple applications. Containers are created using Docker. Thank you so much. All right, so we have a lot of information here. And at least we have cemented our understanding on virtual machines. And now we know how EC2 instances are virtual machines. And so we are going to learn how AWS also allows us to not just run virtual machines, but also run containers. That is what the ECS is about and what the EKS is about. So what we are doing now is to building the foundation to understand the concept of containers and containerization. And over here, this is similar to what AWS is going to do. Tomorrow we'll get into details and we understand. So we are seeing that the virtual machines are there underlying here, and there are multiple containers. Now we are talking about how to work with a container. In the cloud, an application may require multiple containers. Please listen to me. An application may require multiple containers. Now that we understand containers, we will talk about another tool, which is called a container orchestrator. Just like we learned about load balancers that are able to manage traffic across multiple servers, we are going to talk about another tool after we learn about containers that can manage all the containers together that are across multiple systems. Once we learn about that particular tool called an orchestrator, we will now understand the container orchestrators that are most popular today. And we'll be able to build our understanding in ECS and EKS when it comes to AWS. What I'm going to do next is to show you another similar video. And this particular video, I want you to pay attention to it as well. And let's add more to what we have just learned. So let's watch the next video. And after that, we'll continue with our studies.
Are you confused over whether you should be using virtual machines or containers? Well, I'm Dom Pizzette, edutainer at IT Pro TV, and in this Versus video, I'm going to show you the differences between virtual machines and containers. Virtual machines and containers can be confusing partly because there's so many players in the space. In the world of virtual machines, we have players like Xen and KVM, the largest open source virtualization platforms. We have VMware's vSphere, Microsoft's Hyper-V, Oracle's VirtualBox. Over on the container side, well, we have Docker, who's the undisputable champion right now, but we also have Rocket, LXC, even Microsoft Windows has their own container platform. So how do we know which one to use? Well, before we pick, let's start with making sure we understand exactly what their purpose is. I've got a little analogy I want to share with you. Virtual machines are based on this idea of virtualization, which is very much like carpooling. When I drove to work this morning, I drove in my car. I have 5 seats in the car. I occupied one. I wasted 80% of the capacity of my car. With virtualization, we put more than one workload on the same piece of hardware to maximize the resource utilization. I could have fit 4 more people in my car. 5 of us could have driven, well, from my house to here, right? We kind of expect a somewhat common workload. With containers, it's different. When I drive, I might drive a motorcycle, a car, a semi-truck. All 3 drive different ways. I have to have different licenses for each one. Containers make them drive the same way. I can actually hop onto a motorcycle, onto a car, onto a semi-truck, and be able to drive it because containers hide all of the complexity underneath and give me a common set of controls that I use to steer and drive the vehicle. Now, let's say we're having to pick between one and another. Let's talk about how they work to understand where the efficiencies are. With virtual machines, think of that carpool analogy. We have multiple operating systems running on one piece of hardware. We have our hardware, and we have some host operating system that acts as a hypervisor. It's like a traffic cop determining who gets access to hardware when. On top of that, we have partitions. And in each partition, we install a full operating system with any binaries and libraries and ultimately the applications we want to run. Each partition has its own completely separate operating system, all running on top of that shared hypervisor. Containers are a little bit different. We still have hardware. We still have some kind of host operating system. But instead of a hypervisor, we have a container engine. And what that container engine is doing is exposing parts of the host operating system into the partitions. The partitions only contain the binaries and libraries, the applications that we need. They don't contain an entire operating system. They don't have to. They can share the kernel of the underlying operating system. By having a little bit of shared resources like that, we lose the separation and independence, but we gain a ton of efficiency. And that's where containers become really powerful. Let's talk about some of the other differences between virtual machines and containers. When we talk about startup time, virtual machines have an entire copy of an operating system. That takes time to boot. It can take a minute or two to boot up and then get customized and up and operational in an environment. Virtual machines are great for on-prem deployments and uses like that, but in the cloud, they can be a little sluggish. Containers, on the other hand, just contain the applications. They're running off of a kernel that's already running. They boot up in milliseconds. That makes them very rapid to deploy, which is great for cloud autoscaling. We also talk about disk space, right? When you have an entire copy of an operating system running in a virtual machine, that's going to consume disk space. And the more VMs you have, the more duplicate data that you have for those OSs, and that consumes extra storage. Containers, they share. They use a container image. They fire up with just their applications. They're far more efficient as far as the storage they consume. Portability. Virtual machines can move between hardware, assuming that hardware is running the same hypervisor. But with containers, most of the container services that are out there are compatible with Docker containers. That means I can write a Docker container, and I know that I can run it on my laptop. I can run it on a server here in the building. I can run it in the AWS cloud or Microsoft Azure. Very, very portable, very easy to move around. We don't really have that with virtual machines. And then just general efficiency. Virtual machines have entire copies of operating systems, so they consume more RAM, more CPU, more disk space. Containers are far more efficient. We're trading a little bit of isolation in exchange for performance and efficiency gains. And then lastly, that operating system and kernel. I've kind of already spoiled this one a bit, right? With virtual machines, you have dedicated operating systems and kernels per virtual machine. So if one VM crashes, it doesn't affect the others. But with container platforms, they use a shared kernel. That makes them more efficient and faster, but if that kernel were to crash, all the containers were to go down. Now, fortunately, they're so small, I can just rapidly redeploy them somewhere else. So that's a big bonus to have with those workloads. All right, so let's sum up some of the differences that we've got here. Virtual machines give us isolated, independent operating systems that we can install applications on. We can run different operating systems on top of the same hardware, and we can maximize our hardware utilization in exchange for a little bit more sluggish performance. Containers, on the other hand, are much faster. They take less space, they deploy more rapidly, and are wonderful for auto-scaled cloud deployments. But they leverage a shared kernel under the hood, and that makes them a little susceptible to not being isolated from the other containers running on the system. Well, that's it for this Versus episode. Be sure to check out the playlist below for more Versus videos, and be sure to subscribe to our YouTube channel. Thanks for watching.
All right. Thanks for watching. So let's continue with our studies. We are still talking about containerization, containers, and container orchestration. We want to move on and talk about Docker. Please type Docker in the chat for me. You can hear me. Please type Docker in the chat for me. Docker, 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 Docker. All right. So just like I've been saying, Maybe a new tool sounds new to you today. However, the fact that you have heard that this is modern technology gives you a responsibility to not ignore it, but to exploit. So today, one good thing that has happened to you in the class is for you to hear that containers are the future and you are being introduced to Docker. So if you have not been using it, at least you know that it is the future. And this logo or icon of Docker, you can see something like containers on a ship. So you can see how it is carrying a lot of containers. So we want to get introduced to Docker. And Docker is a platform, an open source platform, meaning it's free. Docker is free, and it is used for automating the deployment, scaling, and management of applications in lightweight portable containers. In short, Docker is a tool that allows you to create containers. And so what we are going to do is to understand that this Docker is something that we will be using. And so all the containers and containerization we've been talking about, at least we have heard that there is a tool that can allow you to be able to create your own container. And so later on, you may have to get into this tool to explore it more, or you may encounter it again in your cloud or DevOps or your future classes. And you will know that this is what is also leading today when it comes to creating containers in the whole wide world. And so later on, you will find yourself working with Docker. All right. So I have a short clip that we'll be watching after we look at the benefits of using Docker. Then we will look at that clip to get a little bit of insight into Docker. Now, the first benefit of using Docker is consistency. Just like the benefits of containers, developers can ensure that an application runs the same way on any machine. So, isolation, Docker containers ensure that applications and their dependencies do not interfere with each other. Scalability, Docker works well with orchestration tools like Kubernetes, which allows for scaling applications across multiple machines. Faster deployment, Docker speeds up the process of deployment or deploying an application by providing a consistent environment. Docker is widely used in software development, in DevOps, and cloud-native application development. So this tool called Docker is the future. So now you have seen why you need to upgrade yourself in the area of modern tools. Previously, when you hear Docker, you probably didn't know what it meant or what it is used for. But now we are telling you how powerful it is and how important it is. I'm going to play a short clip about Docker, and then we will move on and talk about something else to set the stage for the remainder of our training. So let me quickly get into that and show you the next thing to look at. The next thing to look at. So I'm going to play this Docker video first, and after that, we will move on.
Hey Dev, question. Do you like it when your software runs? If yes, then try Docker. Docker is the software tool that makes software tools more useful. Run applications anywhere, collaborate with anyone, and waste 0 more seconds fixing outdated documentation. So go ahead and burn your setup notes, because Docker means the end of installing everything directly on your machine. Here's how Docker brings developers up to code. Docker keeps all your work inside a container, walled off from everything else in your machine, so your machine runs better. Containers use images that carry everything needed to run anything. Each image is a working set of tools that let you jump right into development, with no repetitive tasks. A container image can hold almost anything you can dream up. A Python script, a database system, an AI model, a game server, a whole ready-to-run application. Whew, that's a lot of things. Start a new idea with a single command from Docker Hub, and clean up easy, because nothing is installed on your machine. Remember? Connect multiple containers for custom architectures, or just try things out next to your production database. You can also use Docker Hub to share custom container images with your development team, keeping everyone on the same versions of everything. So you'll never hear this again.
What worked on my machine?
New tools arrive all the time, because Docker is obsessed with being helpful. If you're like 99% of developers who just want to sit down and code, use containers. Install Docker Desktop today.
All right. So we've heard of Docker. We've been introduced to it. We've been told what it does. We understand that it is a future and is currently the leading container image creator, or what allows you to create containers today. There are other tools, but Docker is number one. I didn't say Dockers. I said Docker. Someone thought I said Dockers. All right. So that is wonderful. And we will be moving on. So let me check what we will be we'll be talking about next. And I think it is time for a break. So let's keep Docker in mind. If you're a tech professional today, you've heard of something amazing and something that you'll be using. And so let's keep it in mind. So I'm giving you a 10 minutes break. Let's return 7:50 p.m. GMT, and we will continue. So today is all about setting the foundation. And tomorrow we'll talk about AWS containerization. So I'll see you in 10 minutes. Let's get up, stretch, and continue. Everybody, I hope you are back and we can continue. All right. Are we back? Thank you. Thank you so much. Welcome back. All right. So I want to believe that we are making progress in our introduction to containerization. Are we making progress? Are we making progress? Okay. Yes, we are. We are making progress. So the next step in this introduction is to talk about an environment where we have multiple containers to manage. So in the cloud, when it comes to AWS and when it comes to the cloud, we deal with multiple containers. And the process of managing these multiple containers is something we call container orchestration. So please put this in the chat for me. Container orchestration. I know you've done it before, but please type this in the chat for me again. Container orchestration. This is the main concept that we want to introduce you to, because after you understand container orchestration, then you can understand the AWS container services. So I'm just going to explain what this is to you. And container orchestration is a process, or is an automated process of managing and coordinating containerized applications. All that we have said right now are just technical terminologies to explain to you the process of managing multiple containers. Please type multiple containers for me. Multiple containers. So in the real world, we may have multiple containers. And the process of managing and coordinating or moderating them is what we are talking about right now. That process is called container orchestration. It manages how multiple containers function across a group of servers or virtual machines called a cluster. And so sometimes we have multiple containers across a cluster. And this cluster here is talking about multiple virtual machines. We understand how we can scale our EC2 to have multiple versions. But then we are running containerized applications. And so when it comes to container management, we need certain tools that are called container orchestrators. And the process of managing these multiple containers is really the foundation we are looking for. And it is called container orchestration. It takes care of tasks like starting containers, scaling up or down, connecting them, networking them, ensuring they work reliably, even if some service in the cluster fails, ensuring that there's no downtime. So think about how, let's say, a load balancer works. This orchestrator, instead of managing servers, it is managing containers. In short, container orchestration is the automated management of multiple containers across a cluster of servers or virtual machines, handling tasks like deployment, scaling, networking, and maintaining reliability. With orchestration, you can manage complex applications with many containers, ensuring high availability and efficient resource utilization. There are some complex applications that will need multiple containers, and so you need container orchestrator tools to manage them. What are the key features of orchestration? One, automated scheduling. Orchestrators are the tools used for orchestration. And these orchestrators automatically place containers based on resource requirements and constraints. Load balancing. Orchestrators distribute traffic evenly across containers to prevent overload. So you can see clearly that the container orchestrators also work as load balancers. This time, managing multiple containers and distributing traffic across containers. This is beautiful. Scaling. Container orchestrators automatically adjust the number of containers in response to demand. Self-healing replaces failed containers and reschedules them as needed. Networking and security. Orchestrators manage communication between containers and ensure secure access controls. Monitoring and logging. Monitoring and logging. Okay, I repeated that. Orchestrators, let me fix that right now. All right, so monitoring and logging. Orchestrators provide tools for monitoring container health and logging to help troubleshoot issues. So these orchestrators, not only do they manage the containers, they also monitor container health. Yesterday, we saw the health of elastic beanstalk, and we saw that when it's green, it means something. When it's yellow, when it's red. So orchestrators also do that. So this time, I want to introduce you to the most popular container orchestrator in the world. So in this lesson, one of the important things we have done is to introduce you to a tool for creating containers, which is Docker, and a tool for managing or orchestrating containers, which is Kubernetes. Please type Kubernetes in the chat for me. Kubernetes. Please put this in the chat for me. Wonderful. Wonderful. Thank you. Now, Kubernetes, again, we've heard of another powerful tool that we need to keep in mind. You know, sometimes we just hear of modern things. Although it has been around for some time, maybe for you it is new. You have to understand that Kubernetes is the most widely used container orchestrator developed by Google and is now maintained by the Cloud Native Computing Foundation. So Google built Kubernetes. So maybe you've been hearing Kubernetes. Now you know what it is. It is a container orchestrator. Not like a container image creation tool like Docker, but this is more like an orchestrator. And so it automates the deployment, scaling, and management of containerized applications. So this is a manager of containers, helping organize and manage containers across a cluster of servers. We understand that. Kubernetes ensures that applications run smoothly, scale efficiently, and recover from failures automatically. What I said is that this is the most widely used container orchestrator in the world. So when it comes to container orchestration, Kubernetes, we have heard today, is the leading orchestrator. And when it comes to creating containers, Docker is a leading tool. Now that we've heard of Kubernetes, we are now ready to learn about ECS. because ECS does the work similar to Kubernetes. So tomorrow we will get into ECS. Before we wrap up today's class, I'll show you one short clip about Kubernetes, and then we'll end. Kubernetes also provides tools for container orchestration, load balancing, networking, and storage management, making it easier to build, operate large-scale distributed systems. So this is the last thing I'm going to do right now, to play a short clip, and we will end the lesson on the notes of orchestration and Kubernetes. So I'm going to play this, and after that, we will call it a day or a night. So let me play this video. And after that, we are good to go. So now we have the foundation for the next AWS service. Sorry about that.
Kubernetes, a tool for managing and automating containerized workloads in the cloud. Imagine you have an orchestra. Think of each individual musician as a Docker container. To create beautiful music, we need a conductor to manage the musicians and set the tempo. Now imagine the conductor as Kubernetes and the orchestra as an app like Robinhood. When the markets are closed, an app like Robinhood isn't doing much, but when they open, it needs to fulfill millions of trades for overpriced stocks like Tesla and Shopify. Kubernetes is the tool that orchestrates the infrastructure to handle the changing workload. It can scale containers across multiple machines, and if one fails, it knows how to replace it with a new one. A system deployed on Kubernetes is known as a cluster. The brain of the operation is known as the control plane. It exposes an API server that can handle both internal and external requests to manage the cluster. It also contains its own key value database called etcd, used to store important information about running the cluster. What it's managing is one or more worker machines called nodes. When you hear node, think of a machine. Each node is running something called a kubelet, which is a tiny application that runs on the machine to communicate back with the main control plane mothership. Inside of each node, we have multiple pods, which is the smallest deployable unit in Kubernetes. When you hear pod, think of a pod of whales or containers running together. As the workload increases, Kubernetes can automatically scale horizontally by adding more nodes to the cluster. In the process, it takes care of complicated things like networking, secret management, persistent storage, and so on. It's designed for high availability, and one way it achieves that is by maintaining a replica set, which is just a set of running pods or containers ready to go at any given time. As a developer, you define objects in YAML that describe the desired state of your cluster. For example, we might have an Nginx deployment that has a replica set with 3 pods. In the spec field, we can define exactly how it should behave, like its containers, volumes, ports, and so on. You can then take this configuration and use it to provision and scale containers automatically, and ensure that they're always up and running and healthy. This has been Kubernetes in 100 seconds. Like and subscribe for more, and you can support my work by sponsoring me on GitHub or by becoming a pro member at Fireship.io for even more content. Thanks for watching, and I will see you in the next one.
All right. So what we have done today is to get introduced to the concept of containers and containerization, and the tools for creating containers like Docker, and also for orchestrating containers. Now that we have built this foundation, You will be able to apply it to AWS and learn about the AWS service that orchestrates containers on AWS. So when it comes to AWS, now you need to look into a tool like ECS. The CCP examination requires that you have an understanding of what this service does. So when we talk about ECS, now you know what to say or what to look out for. I want to know if you have learned something today. Yesterday's class is ready. You should have it shortly. Have you learned anything today? Anything at all? Let me see. Maybe one person has learned something today, or maybe two people or three. I bet says, yes, I've learned something today. Lois says a lot. Thank you, Lois. Thank you. Well done. Thank you, Ato. Thank you all. Thank you. And on that note, this is where we draw the curtain, and I'll see you tomorrow.